Welcome. I am Jason Couch, and this is a presentation on the concept attainment model of teaching. The first question you may ask is, why would you want to use the concept attainment model of teaching? Not all of the terms and ideas that a student needs to learn are necessarily equal. Some of the ideas that a student needs to understand are so central to the concept that if a student doesn't understand them well enough, they are going to struggle further down the road. So the concept attainment model is a strategy that can be used that allows students to understand a concept and be able to apply that conceptual knowledge to form bigger ideas. This is done by exploring the relationship between big ideas, such as classification and categories, so concept attainment supports students' deep understanding of concepts and helps them to develop conceptual knowledge. So concept attainment is the search for and listing of attributes that can be used to distinguish exemplars from non-exemplars of various categories. Students are going to understand what a particular concept is by seeing what it is and what it is not. The concept attainment model can help build on learners' natural capacity to compare and categorize new ideas, and the process can be presented to students as a sort of game that is being played instead of as a traditional model with the fire hose of information. Hilda Taba, one of the theorists behind inductive thinking model, promoted the use of concept attainment because its ability to support the needs of diverse student populations. One of the key concepts of concept attainment is that it gets students thinking. As with other kinds of inductive strategies, students are challenged to think more. They're expected to use their own processes of reasoning, analysis, and logic to arrive at an answer. In this way, it engages higher cognitive function among learners and promotes learning ability. Another one is that it creates a strong foundation. As a contrast to more traditional forms of teaching, inductive teaching models such as concept attainment can promote a deeper understanding of the subject being taught. And then lastly, it promotes lifelong learning. Like other inductive strategies, concept attainment encourages a culture of curiosity and questioning that can last a lifetime. The work of psychologist Jerome Bruner laid the groundwork for concept attainment. Bruner's theory of cognitive growth describes how learners perform better if they're allowed to discover information for themselves through a process of reasoning and exploration. As Bruner was one of the early proponents of constructivism, it's no surprise that Bruner's model of concept attainment is supported by cognitive constructivism. In both concept attainment and cognitive constructivism, learning is presented as a process of active discovery in which the teacher facilitates the discovery by providing the necessary resources and by guiding the learners as they attempt to assimilate new knowledge. Social cognitivism is also supported by the model, as the cooperative learning in concept attainment corresponds with social cognitivism's ideas that learners engage with content and interact with one another in order to develop an understanding of the content. According to the literature, concept attainment can help students develop an understanding of a concept through the examination of examples and non-examples and the analysis of their attributes. While the model of concept attainment was initially designed to help develop conceptual knowledge, concept attainment also helps to support the student's acquisition of strategies and reasoning and critical thinking. Some more benefits of the model that have been suggested by research are that it also supports retention, engages students in active learning, supports higher order thinking, and capitalizes on students' prior knowledge. There are 4 phases of concept attainment. Phase 1 is the presentation of examples. The teacher presents examples and non-examples and then asks students to form a hypothesis of the concept. Students record attributes of the examples and non-examples. In Phase 2, the formation and analysis of hypotheses, the students form and record hypotheses about the concept. They must also substantiate their hypothesis with data from the examples and non-examples. The teacher then asks students to examine their hypotheses, verify or refute their hypotheses, and then challenges students to support the hypotheses with data. In Phase 3, closure, the teacher asks students to summarize the critical attributes of their concept, formulate a definition of the concept, and then reflect on the entire concept attainment process. The last phase, application, the teacher asks students to apply their knowledge in novel situations, so students will apply their knowledge by locating, changing, or creating other examples and non-examples. Okay, so let's look at some instructional scenarios. In this lesson, a 7th grade art class is going to learn about the concept of symmetry in works of art. So the goal is that they will be able to determine the essential list of characteristics of symmetry in a work of art. The teacher needs to have a presentation of examples and non-examples of works of art. This can be done via PowerPoint or having actual physical examples printed off. The only other things needed are pencils and papers for the students, although those could also be substituted with a device of some kind. In Phase 1, the teacher is going to introduce a game that the students will play to learn a new concept. Students are told that they will be shown examples and non-examples and will need to write down the different attributes of both. They will need to figure out the common characteristics among the examples and hypothesize what the concept is. The teacher will remind students that some attributes will be common in both examples and non-examples. Some rules for the game. The students need to keep their hypotheses private. They need to write down their hypotheses as they are presented in the examples and non-examples. They need to concentrate on what the examples have in common. Students need to list the attributes of the concept as examples and non-examples are presented. Students need to eliminate or cross out the attributes that are not presented in examples. And then the students also need to form working definitions of the concept as examples and non-examples are presented by writing down their definition. They also need to remember that non-examples may have some attributes of examples. And the last rule is that they need to be prepared to discuss their hypotheses and support it with data from the examples and non-examples. In Phase 2, the teacher is going to then present the examples and non-examples, and the students are going to start to generate a hypothesis based on the examples and non-examples. The teacher will identify the examples and non-examples when they are presented to the class. Some teachers choose to do this by calling the examples a yes and the non-examples a no. So as a teacher presents the first example, they would say, this is a yes, and then a non-example, this is a no. So the teacher may want to ask the following questions. So the first one could be, what attributes does this example have that is similar to that example? And then another question could be, how are the attributes different from those presented in the non-examples? They need to explain and justify their reply with data from examples and non-examples. Another question is, what similarities and differences have they noticed between the examples and non-examples? And then as students begin to analyze their hypotheses, the students will share their hypothesis with a partner and then discuss their definition of the concept. The teacher will then reveal at the end of this phase that the concept is symmetry. In the third phase, the teacher is going to ask students to develop a class definition of symmetry and then reflect on their learning of the concept. What did they learn? How did they learn it? And what did they learn about analyzing the examples and non-examples, and if they were surprised about their initial hypothesis. In the last phase, the teacher is going to give some additional examples and non-examples and ask students to change the non-examples into examples or ask students to create several examples that could have attributes of the concept. Okay, so this is the second instructional scenario, and so this one is a 5th grade science class that's going to explore the concept of how insects are classified. So the goal for this lesson is for the students to be able to determine the essential list of characteristics for insects. So the materials are similar to the last scenario, and so the teacher should have an insect presentation or physical representation of the insects, a picture of each of the insects and non-insects, and then a pencil and paper or some sort of device to record information. So the phases are the same as the last scenario, and so the teacher is going to introduce the game, and then they're going to begin with a presentation of the examples and non-examples. In this scenario, it would probably work best if the teacher used physical pictures of the insects and then on the board had a column of yes and a column of no, and then started to present the first insect and say this is a yes, and then a non-insect and call it a no, and then after a few examples and non-examples, show either an insect or non-insect, and then ask the students if they think it's a yes or a no to kind of get them going into what their hypothesis may be. And so all of the other phases are going to work the same. They're going to generate their hypotheses, and they're going to develop a class definition of insects, and then they're going to be asked to reflect on the learning of the concept. And then in the last phase, the students are going to start the students will be given either an example or non-example, and then ask if they're given a non-example, like what does this non-example need in order to become an example? So you show a spider, and then what what attributes of the spider would have to be different in order to be considered an insect. The role of the teacher in concept attainment is a facilitator. The teacher will show the students how to work through the model and will guide the students to the right path when they start to stray, and that is likely to happen when they're trying to figure out what the concept is. The teacher will also need to help encourage the learning reflective process, as that is the last part of the lesson, and this is probably where the model will start to shine by helping students show not just what they learned, but the process of how they got to that learning, and give them the ability to more easily understand how they can organize and categorize information and use that process in order to understand further concepts. The role of the learner in the model is to be an active thinker and participant through the learning process. The student needs to build knowledge through experience and to draw conclusions and construct their own knowledge. At the conclusion, the student also needs to reflect on their understanding and how it relates to the new information that they've learned. So let's look at some of the advantages and disadvantages of the concept attainment model. One of the advantages of the model is that it provides a teacher with an opportunity to analyze a student's thinking process. This is not something that you really get to see in action a lot of the time in a lot of teaching models. Students are also going to gain experience in creating a hypothesis and organizing their findings. The students are also required to pay attention to details when they organize their information. This is probably one of the areas where you're going to have to remind students when they are conducting this type of model for the first time that they need to pay attention to the details. This model can help students expand their thinking to be able to view and consider multiple attributes at the same time. So there are some disadvantages to the concept attainment model. Those details are an advantage, but if the students aren't using them, then they will easily get lost in the weeds and they're trying to figure out what this concept is and they don't really understand because they haven't paid attention to all the details. Another disadvantage is that there are some complex issues that you really can't tackle with concept attainment, and if you try, it's going to become very frustrating for the students because they're never going to stay on the right path and they will just get more and more frustrated and then probably shut down. And so an important part of concept attainment is knowing what concepts you can use in the model and which ones you need to use a more traditional model. So another disadvantage is that the model is a lot more work for the teacher on the front end in creating the lesson for it. Most textbooks are not set up to provide enough examples and non-examples for a concept, and so the teacher is going to be doing a lot of the work on their own. And the last disadvantage is that students need to understand that their hypothesis is probably not going to be correct the first time it's stated, and some students really have a hard time with not being right the first time, especially gifted students. They're expected that they will know the answer, and when they discover that they're often wrong a lot more than they're right in the beginning, that can be really frustrating for them. One of the ways that these types of lessons can be adapted for diverse learners is in the content. Specifically for ELL students, the use of images for the examples and non-examples will be much more easier to understand versus text. Another issue for ELL students that the teacher needs to be aware of is cultural differences when they're selecting the examples and non-examples. It doesn't really apply to the two instructional scenarios since they were symmetry and insects, but if there is a cultural component to your examples and non-examples, you need to be aware of what your students are probably going to understand and what they won't. Another way to adapt the model is via the process of instruction. So a teacher may want to have the activities conducted via small groups instead of using a whole class setting, or have the students work in pairs or in mixed ability groups. Lastly, the product can be adapted for the model. So the product that's produced by the students, in the first scenario, the students who struggled with written expression of their hypothesis could instead produce a drawing of a symmetrical design. So this would also be a good place for adaptation for gifted learners. In that symmetry lesson, they could expand to different types of symmetry. They could look at reflection, rotation, translation, and then compare those attributes as well. And so that is the concept attainment model. Thank you for watching my presentation.